Welcome to EMC Test Design. Today we're going to talk about our Smart Fieldmeter kit. Here you see this kit in a hard case. What's included into this kit? First, you could see there is a manual. This manual inside has calibration certificate with all data taken when we calibrated this unit, this particular meter with this probe. Inside the unit you see the meter, model RFP-04. There is a probe. It can be PI-01 or PI-03 in most cases, depending which one you bought. Another part is tripod. This is 6-inch table tripod, and we can use it to mount and to place this instrument on a table. There is also accessory kit. Accessory kit consists of 3 parts. One part is shielded RF cable that is used to connect probe to meter. Second part is a special cable that is connected between remote output of the meter and PC link kit. Finally, last part is little plastic clip that is mounted on a probe and allows it to connection to tripod. Now let's mount probe on the meter. It's done very simple by using gentle force. We screw probe to the meter. Now they are connected. Now let's mount meter on a tripod. It can be done very easily by using mounting that is already available on this tripod. You can adjust orientation of the probe and the system is ready for measurements. Let's talk about controls. There are 3 controls: on-off switch, mode switch and range switch. On-off switch is self-explanatory. Mode switch allows you to choose between average reading when averaging time is 300 milliseconds. Second position is pulse position. In this case, reaction time of the meter becomes 50 milliseconds. And in upper position of the switch, the reaction time of this meter up is 50 milliseconds and down is about 17 seconds. This is necessary to be able to identify the nature of the signal you're trying to measure. If the reading does not change when you go from average to peak pulse, it means that you have steady state signal. If you have signal that is dynamically changing, you will get different readings. This meter has one very unique feature. It's called auto-zeroing. When you turn unit on, you could see this green light. It comes up not instantly, but after a couple seconds. This happens because unit goes through auto-zero routine that allows you to produce very high accuracy when measuring low fields. When you switch meter between sensitive ranges, you could see that you have a blink of this green LED, and when green LED comes on again, it indicates to the user that unit have been auto-zeroed and is ready for measurements. This unit is powered by 9-volt battery and it will operate for about 100 hours. So there is no very frequent need to change the battery. If such need arises, you remove 4 screws from the bottom and battery can easily be removed and replaced. What makes Smart Fieldmeter a professional test instrument? It is a calibration. We calibrate every unit that we produce in our test lab by using secondary EMC test standards that we once in a while send to United Kingdom Physical Lab for calibration. Figure 1 shows linearity plot of this meter and probe that we tested versus reference field. You could see that field is changing from 0.2 volts per meter to 400 volts per meter, and this is axis X, and on axis Y you could see the real reading of the meter. If you have ideal instrument, you should get a straight line. Any deviation from straight line means linearity error. In our case, linearity error is in the order of plus minus 1–1.5 dB, depending on the field. This figure shows so-called frequency correction factor. Because probes that we make does not have absolutely flat frequency response, we need to make correction at each frequency. Typically this correction is not very big. In the domain plus minus few dB. But if you want to increase accuracy of your measurement, you can, for every known frequency, you can take into account frequency correction factor. This plot actually shows measured frequency correction factor that you need to use. In this case, you need to use this number and multiply the reading of the meter to get a real field strength value. Keep in mind that the probe that we make is isotropic. It means that its reading changes very little when field strength vector changes its direction. Parameters that we measure for each probe that identifies its isotropicity is rotational deviation when we rotate probe around its axis. Typically it changes between plus and minus 0.5 dB to plus minus 0.7 dB depending on frequency. Calibration intervals that we recommend to most of our customers is 2 years. After 2 years, if you want to keep your instrument calibrated, you must send this instrument to our lab for calibration. In many cases, your customers or your specific lab requirements may demand calibration every year. In this case, yes, we can do it every year, and every year we will provide you with calibration certificate that will make sure that the instrument that you use has good accuracy. With every broadband kit that we sell, we supply another component. This component is called field gauge. Field gauge allows you to test operation of your meter, probe and quality of interconnecting cable right in a field in a second. Operation of field gauge is extremely simple. You take a probe and plug into the opening of field gauge, and you push a little bit until you feel that the switch turns on and you see green LED. At this moment you read what display shows. Typically this is a reading of about 10 volts per meter, and this reading is specific for your meter and probe, and we will supply this reading when we calibrate the unit. Using a field gauge is a verification of operation of your system, and it is not a substitute for regular calibration that we advise you to perform every 2 years to ensure that your instrument is calibrated and operates properly.